record from 1961 to 90. That's what we're calling normal. So that's real data collected at the airport. The second, third, and fourth columns, 2020s, 2050s, and 2080s, are periods in the future. And those are periods that are actually averaged over 30 years, centered around a particular date in question. So the 2020 period might be like from 2010 to 2040. And that's a 30-year period average. And similarly for the other points in the future. So if you look at the table, you can get a sense that, yes, average temperatures are going to increase. And just to make it a bit more understandable, I did put it in a graph. So there are five clusters of bars here, the 4 seasons and then annual. And then in each cluster you have, first of all, things in the chart, the historical period, from the 2020s, the 2050s, and the 2080s. So without really getting into the numbers, you can just look at that. You can see, in general, the average temperature is going to be higher. Then, similarly, I have information about precipitation in the future. And I've graphed it, and you can see that, interestingly, the precipitation pattern is more complex. It's not a uniform increasing overall. In the winter, we can see that precipitation will increase over what it is now. But in the spring, precipitation may decrease as we go farther into the future. Then in the summer, they're saying for the first few years it's going up, and then it's going down in the future beyond that. And you can see the precipitation is going to be much more the wild card in the future without even needing to know what the actual numbers are. We make a lot of assumptions the way we manage our infrastructure, like how big culverts are and ditches for catching runoff from designed storms, and how big reservoirs need to be to collect enough rainwater in the rainy season to supply a community throughout the season. So a lot of these assumptions may have to be revisited in the future. Another really useful measure is extreme precipitation. In general, the models are saying that precipitation, even though we'll get more overall, it may come down in fewer, more intense events. So instead of more rainstorms, we might have fewer rainstorms, but much more intense rainstorms. So again, graphing it, you can see that the number of intense rainstorms, or not the number of intense rainstorms, but the size of the intense rainstorms is going to increase. And then finally, one other measure of the future is what we call the growing season length. This is essentially a measure of the number of frost-free days throughout a season when you can grow things. And you can see that the number of days that you could grow things could increase significantly over the current period. So potentially this has a lot of useful information if you're planning for the agricultural or gardening sectors, because in the future the temperatures may be higher, the growing season will be longer, and we may get more precipitation. So if you're a farmer in the area, you might start to think about growing potentially different crops in the future. So that's just a really quick snapshot of what the climate may look like in the future. So what are some of the impacts of these changes in climate? Well, I mentioned changes in precipitation patterns, potentially heat waves and air quality problems. Air quality problems more so in areas that are currently experiencing air quality problems. These will be exacerbated. Sea level rise, certainly an issue in Nova Scotia. Lake level drop, I also mentioned that because that's a huge concern in southern Ontario. The Great Lakes are expected to be lower in level in the future, and that will have huge implications for shipping on the Great Lakes, particularly through the Port of Montreal. New pests and diseases, insects and other things that might be able to come here during the summer or come on ships, that currently they can't, because they're tropical, they can't survive over the winter. The winter freezes them, they die, so they're kept in check. But as the winters become milder, they may suddenly be able to stay longer. So this may have impacts to the forest, to the agriculture sector, even human health. Overall, we're expecting a decrease in biodiversity because these changes are going to happen so quickly that the plant and animal kingdoms will have difficulty adapting to them. Over the long term, they certainly will adapt and biodiversity will come back. But the short term, like the human perspective, is based on, we'll see a decrease. And as I mentioned, longer growing season, that's potentially a benefit of climate change. And one of the key messages of adaptation is we're not just worried about the bad things, we're also looking for advantages, for opportunities to take advantage of. And that might be longer growing season, it might be a longer tourist season, it might mean less heating costs for your home during the winter, things like that. And changes in intensity and frequency of extreme events, I mentioned that. More intense rainfalls, more winter storms, more windstorms. And finally, storm surges and coastal erosion. These are certainly concerns now, and the climate models are showing that these could be more of a problem in the future. So, in terms of sea level rise, this is probably the biggest concern in Nova Scotia, being a coastal community, a coastal province. The IPCC study in 2007 that I mentioned came up with some numbers for sea level rise, and they estimated it to be anywhere between 18 to 60 centimeters. That was like the huge range based on a lot of different factors. But the best guess was it's going to be about 40 centimeters over the rest of the century. So, about that much on average, the ocean could be that much higher. So just to give you a sense of where these numbers came from, well, everybody knows about melting of Greenland, melting of ice mass. Well, in this model, that's only about 10 to 15% of the sea level rise. Another major contributor is melting and mountain glaciers. Essentially, this is ice on land, other than Greenland, that could melt and contribute another 15 to 30%. So we're still missing about 50% of why the sea level is going to rise with climate change. And the really big one is thermal expansion. And this is the idea that as the ocean water gets warmer, it actually expands. And the ocean is a huge basin that's soaking up a lot of heat from the atmosphere, more slowly than land, but it is taking it up nonetheless. And the density is decreasing, and that's where most of the sea level rise is expected to come from. And then there's a lot of interest about Antarctica. The Antarctic ice sheet is of great concern to scientists for a lot of reasons, but it could contribute either way to sea level rise. And some of the models are suggesting that the ice sheet may actually increase in volume because the continent of Antarctica is so cold that even if you raise the temperature, say 5 degrees, it will still be well below freezing. But at the same time, if you raise the air over the oceans around Antarctica by another 5 degrees, that air can suddenly hold more moisture. And when that moist air goes over the cold continent, it will actually drop more snow than is currently experiencing. So with regard to sea level rise, the Geological Survey of Canada did a big study of all the coastlines of Canada to try to classify how sensitive they were to climate change. And they labeled them as either, their sensitivity is either being low, which is the green, medium, which is the orange, or high, which is the red. And if you look around Canada, most of the coastline is either green or orange, except for a few places in the country where there's a lot of red. Does anybody see a lot of red on that map? Pretty close to home. There's a big patch of it up in the Arctic and a lot down in the Maritime provinces. So if I zoom in on the map, you can start to see where some